Hi, thank you for coming to check out my poster. My name is Jessie Thindertum, and I'm currently a third-year PhD student at NC State. The research question that I'm exploring is if we can use high-strength reinforcing steel and reinforced concrete bridge columns. First, I'm going to address the restrictions of many design codes that limit the use of high-strength reinforcing steel in members that form plastic hinges. This is due to lack of research to quantify how it behaves specifically under seismic loading. There are many advantages to being able to use grade 80 steel, which includes an optimized design that reduces material costs, construction time, and most importantly, congestion. This brings me to the start of our study at NCSU. To quantify the behavior, we first had to conduct material tests to obtain the material properties of grade 80 steel. In the next step, a total of 20 large-scale columns tests are being conducted. In the last step, we are studying the demand required in column design. To further study the reinforcing steel behavior, the buckled bar tension test was developed to mimic the load simulated in our column test. These results were able to correlate well with test results, and the conclusion was made that higher critical bending strength can result in better performance. The BPT test was conducted on various reinforcing steel, and it was identified that the Quentin self-tempered manufacturing process and rebar geometry large rib radii were key parameters in improving the seismic performance of the steel. Finally, these key parameters were tested in large-scale column tests, and our test setup applies quasi-static loading to simulate similar loading applied during an earthquake. We loaded the columns to the exact same load history as the grade 60 columns, and the only difference being the strength of steel, reinforcing steel. It was found that the grade 80 columns was able to sustain higher displacements and more cycles than the grade 60 column. Future tests will further explore key parameters of grade 80 steel. The last step is to understand what strain demand is required for design. A fiber model was developed and calibrated from column tests. The results will give us an understanding of the strain demand required for column design. Finally, we can draw some preliminary conclusions that grade 80 rebar can match and sometimes exceed the displacement capacity of grade 60 steel. This is promising to be able to improve the overall design in seismic areas. Thank you for listening. I just wanted to take a second to thank my project sponsor, the California Department of Transportation, and the technical staff at the Constructed Facilities Lab at NCSU. If you have any questions, feel free to email me. I'm happy to talk further about this research.